Alright, welcome to the rare after work video, or at least it used to be rare. It's going to need to become less rare because the test is right around the corner, faster than I could possibly imagine. Unfortunately today I did not check in with my boss to see when I'll have off. It's going to be in December, so I'm going to need to verify that soon because I need to know if I'm going to have to request time off from work in order to take this test, or if I can just use one of the days I'll already have off for the holidays. So let's actually go ahead and look at the registration site and see what dates in December are available. So I mean, I guess I can pretty much assume that I'll have the whole week of Christmas, but let's see here. So here we go. So yep, so we'll click on exam registration, make sure we've got the right kind. So yep, this is the schedule. This is exactly what I'm looking for. So yeah, like I'm pretty sure I have off. You know what? I bet you it's this week. So here's my calendar. Here's December. So yeah, I'd be willing to bet that this is the week I have off by default. So maybe I can take it. Yep, the 11th I'll have. So yep, unfortunately it looks like it looks like I will need to take some time off from work to take this exam, because I bet you the week I have off is the 21st, and then I'll be starting work again in the new year. But I'll have to double check that, because if I do have this week off as well, I definitely am going to register for one of these. And if it turns out that I can't, there is no exam date where I can just use a day I already have off and I have to take off time. If that's the case, I'll probably just do it earlier, because I just want to get it over with. It's been like a huge journey, and I'm ready for the journey to come to an end. So, but the most difficult, arduous trek is right now, because I really gotta hit the gas and move faster, because we see, like, you know, I had that mistake where I didn't know what the source address was. I'm definitely not ready to just go and take it tomorrow, so that's why I'm doing a after work video. I'm gonna do at least a half an hour, but I don't think I'm gonna expect myself to do an hour. Just the fact that I've got the camera rolling and I've got the lab up and everything is better than I've been doing. So yeah. So the last video, I was able to ping end to end. I found out that I needed to use the correct source address. Now, there is one thing I was really confused about that I think I would like to dig in a little bit deeper this video. Although I would like to move on as fast as I can to the next topic. But I mentioned it in the last video. What it is if I take a look at the configuration and the export policy applied to BGP, we can see that it's exporting all of the directly connected routes. But if I do a show route protocol direct, we can see that I'm going to be exporting two different routes. So, yeah, that's what we see. So if I look at the show run and I look at what's being exported into BGP, and I notice that it's directly connected, in my opinion, I can safely assume that these are the two routes that are going to be passed on. Well, let's see what actually happens. So if I go to router B and I do show route protocol BGP receive protocol, and I don't know what the, yeah, so show route BGP, show route receive protocol BGP, and then the neighbor, which is going to be 2.168.198.1. Okay, so we can see here we are receiving two different routes, just as I had predicted. So let's go over to router C, take a look there. Now the thing is, the routes won't show up on router C because it's the routes are, sorry, they will. If router C was a P router, if we had an extra router here and it was just a router for the traffic to transport through, not to either take traffic from the customer or send it to the other ISP, then there'd be no way to check the route because it's just seamlessly flowing through it as a label. But here it is going to be de-encapsulated and show up in the actual routing table. But it's going to show up in the routing table as a L3 VPN route. And as you can see, this is where it gets odd, because we can see we've only got the 10.10.10.1 route, but for some reason we've lost the 192.168.198 route. So let's take a look at the configuration on router B and see why only one of those routes made it into the BGP L3 VPN.0 table. Okay, so here's our BGP configuration. So we can see we've got a internal address. Let's take a look at what's being advertised to this address. So show route advertising protocol BGP. Yeah, so we can see we're only advertising one of the routes. We're not advertising both routes. So let's try to figure out why only one of the routes got advertised. So it looks like okay, so this might be it here. Let's get a cleaner output. There we go. So what we notice is that, let's do a show route again. Yeah, so here we have the VPN routing table, and okay, well this is just .2. What happened to, okay, .1. Okay, so .1 shows up here. Aha, so I understand. So the reason it's not making it, the reason only 10.0.0 or 10.10.10.1 made it, but the other directly connected route on router A, the 192 route right here, the reason this one didn't make it is because we can see that this route is only known as a BGP route. It's not also a directly connected route because it was a loopback route on router A. So we can see that route is going to be directly connected on both of them. Directly connected on router A. Both of those routes are going to be directly connected. But if we go over to router B, so yeah, let's do a show route protocol direct on both sides. On this side, we've got the loopback address that is directly connected to this router, the address on GE001 that is directly connected to this router. On the other side, the address on, GE000 is directly connected, but on the other side, the address on GE001 is directly connected to the router, but of course the loopback is not. It's only directly connected to router A. So if we look at the routing table for that route, it's a BGP route. It's not a direct route. So let's take a look at what kind of routes are allowed to go into the VPN. So here's the routes that we're allowing into our VPN. They're specified in these policies here. And you'll notice BGP routes only. We're not allowing any directly connected routes into our VPN. On router A, we are sending directly connected routes to BGP, but after they've gone into BGP, and mind you, the 192.168 route is in BGP. It is learned on router B as a BGP route, and we can see that right here. It's learned in the custom routing instance as a BGP route, but the thing is, it's not the preferred route because the administrative distance is 170 for BGP, but it's 0 for direct. So even though it has a backup route it can use, that is BGP, the fact that the route that is chosen for this and that is actively being used is direct means that it's not matched by our policy, which is only allowing BGP. So this is why only the 10.10.10.1 route made it in there and the 192.168.198.0 route did not. Because on router B, we're only allowing BGP routes to go into the VPN. And yes, the 192.168.198.0 route is learned as a BGP route on router B, which makes a lot of sense because it's being injected into, or it's being exported into BGP on router A. However, it's also directly connected route on router B, and directly connected routes are always preferred over BGP routes unless you change the administrative distance or do some sort of extra configuration to prefer the BGP route. Therefore, that route does not pass the matching criteria in the policy and ends up being rejected. Alright, so I'm really glad I figured that out. I was really confused about that. So let's look at the next example. Okay, so the next example is going to have fewer routers. It's going to be interprovider-ebgp instead of -ISP. Not sure what the difference is, but we'll find out. Okay, so interprovider VPN example multi-hop MP-EBGP with P routers. In this example, labeled IPv4, not VPN, IPv4. Okay, so that's the big difference between this and the other one. Let's take a look at what the other one said. Yeah, so in this example, all routes learned from the CE routers are sent over both service provider networks as VPN IP4 v4 routes, but in the example that's not -ISP, that is EBGP, it's going to be sent as labeled IPv4 traffic and not VPN IPv4 traffic. So routes are exchanged by the AS border routers, router C and D, and provide MPLS connectivity between the PE routers. Router G and H are provider routers. Network topology of the interprovider VPN example multi-hop MP-EBGP illustrates the network topology used in this VPN example. Only routes internal to the service provider network should be announced between router C and router D. Configure this by including the family INET labeled unicast statement in the IBGP and EBGP configuration on the PE routers. When you set family INET labeled unicast, the local router announces internal routes from the INET.0 in the following manner. If a label exists for the route, the local router creates a label, performs a swap, and announces the route from INET.0 with the label. If a label does not exist for the route, the local router creates a label, performs a pop, and announces the route from INET.0 with the label. Routes learned from the labeled unicast session are placed into the INET.0 routing table. In addition, if you configure a multi-hop eBGP session between the end PE peers, router B and router E, in condition we're going to do that. This additional MP-EBGP session allows the announcement of VPN IPv4 routes and allows you to maintain VPN connectivity while keeping VPN IPv4 routes out of the core of the network. So, so the next part is going to be the configurations. So we're only going to need so we are going to need 6 routers, I guess. I guess I'm a little bit confused why there weren't results for 6 routers. Yeah, I only see results for 4 routers. Wonder what router B is. I think they just, okay, so yep, router A is configured as a CE router, so it's just going to be simple configuration, so simple they're not even listing it, using the routing instances statement. Okay, that's interesting. I'm not sure what they mean by using the routing instances statement. Let's see if we have routing instances on here. Okay, so we don't have any routing instances on here, so I'm not sure how they mean that to be configured. Oh, I see what they're doing. So they're just simulating router A using a routing instance. So I think. Oh, no, they're not. Okay, yeah, they're just leaving it up to the person configuring this to figure out how router A needs to be configured, it looks like. Because they exchange VPN IPv4 routes, router C and router D are configured as PE routers. In the BGP group to IBGP, include the family INET labeled unicast statement to pass labeled IPv4 routes, and configure an eBGP multi-hop session to pass VPN-IPv4 routes. Alright, so let's reconfigure router B now. I'm not sure how router A is meant to be configured, but we'll skip that for now and come back to it. Alright, so let's clear out the config. I'll just do a config private, I prefer that. Show pipe display set, pipe no more. Delete, yes. And then these 4 lines. Kind of tempted to just start by doing that with all of them. I think that's going to be a better bet than just getting confused with things I already have configured, things I don't have configured. So yeah, that's what I'm going to do, is just clear them all. I'll come back to router A and router F after I configure these 4 routers. It shouldn't be too difficult to figure out what was needed. Alright, time to do the real config. It's going to be on router B. Let's get going with that. Oh, and I am actually getting really tired. I wanted to go until 9, but I might have to throw in the towel. I'm pretty happy with this video already. Figuring out why that second route wasn't making it in the table was a huge victory for tonight. Okay, so we've got a different kind of family INET traffic. We've got labeled unicast. Let's see the other options. So here are the other options. for family INET. I believe if you want to choose even different options, yeah. So the last option we chose was INET-VPN. This is IPv4 layer 3 VPN NLRI parameters. Here we're going to go with INET, so it's not going to be a part of a VPN. But we're going to add this special knob at the end. So we're going to do INET and then label unicast. So we're going to include label unicast NLRI. And we're going to do resolve VPN, which is install received NLRI in INET.3 also. Okay, so a lot of differences there, but hopefully nothing too difficult to understand. Okay, and I think I'm gonna give it up after this. Love to do more, but unfortunately, once it starts getting late, I really kind of lose my ability to stay up very rapidly, kind of in an exponential, at an exponential rate. Okay, so this is going to be a core facing link. So, yep, in this case it's going to be 000. And I need to check that because we're only going to be adding the core facing link. Same thing with RSVP. Okay, so we just got the routing instance and then the policy options left. This is going to be a custom routing instance, a VRF. Okay, and this is going to be the customer facing port so that we can put the customer traffic into the routing instance. Oops, so I accidentally made the wrong group. Let's delete that and then try again. Oops. Oh, I see, because it took me into the group. Okay, so it didn't create a group. That's good news. Okay, unfortunately that's all I'm able to do for now. Oops, and it looks like we've got a problem here. I assigned GE001 to the custom routing instance, so I can't add it to the default routing instance. Let's take a look at the protocols MPLS configuration in closer detail. Just going to show pipe display stat relative. Okay, yep, so I've got both of them in there. I just need the core facing port. I don't need the customer facing port in there, so let's delete that. Okay, so hopefully it'll commit now. Oops, so I forgot to include the autonomous system. Now I'm not sure which autonomous system is meant to belong to, so hopefully there's a route distinguisher or something like that. Okay, so we've got multiple PRASs here, PRAS statements. I do believe it's meant to be in, okay, so the CE is definitely meant to be R9, the other side is meant to be 10045, so I think this is meant to be something that's not specified here. And unfortunately we can't look at the CE to figure it out. But what we can do is look at BCD. D will be pointing to C, and B is going to be in the same subnet as C. So let's just open up another terminal here. I'm really running out of energy, but hopefully I will be fine. Okay, so yep, PRAS is 10023. That's going to be the proper one. Oops, and I did a show instead of a set. Perfect. Alright, so we're in commit city right now. And hopefully, there we go. So property tax is not too high. Was able to commit properly, but unfortunately all I got through was router B. I do need to stop. I'm very, I am definitely unable to continue. So thanks for watching, and I'll see you in the next one.